Welcome to Aptitude for Placements, and my name is Ranjit. I have conducted this aptitude training program at various engineering colleges all over India, and every year thousands of students get placed by attending this aptitude training program. Here you will find all the questions that are commonly encountered in most of the aptitude tests. These are the questions that keep on repeating in many of these tests. So just familiarize yourself with all these questions and you will have a clear advantage when you attempt your actual placement test. Let's start. A trader mixes chicory costing rupees 20 per kilogram with coffee costing rupees 80 per kilogram in the ratio 1:3. So initially they are mixed in the ratio 1:3. Now price of the cheap one is 20 and price of the expensive one is 80. So first of all we'll just find out the mean price or the mixture price. So we'll just substitute into the mixtures and allegations formula and we'll find out the mean price when they are mixed in the ratio 1:3. So substituting into the formula, price of the expensive one 80 minus mean price, that is what we need to find out, divided by mean price minus price of the cheap one 20. So we'll just solve this. You will get m minus 20 is equal to 3 times this. So 3 into 80 gives you 240 minus 3m. 3m I'll just bring to this side, so you will get 4m is equal to 240 plus this 20, that is 260. So m you will get it as 240 by 4, that is 130 by 2, that is 65. So mean price you will get it as rupees 65. I'll just continue with the question. If the cost of coffee drops to 70, so from 80 now it has dropped to 70, now it costs only rupees 70, then in what ratio should he mix the two so as to leave the cost of the mixture unchanged? Now the cost of the mixture or the mean price is 65. This 65 should remain unchanged. Now find the ratio in which they should be mixed. When the price has now dropped from 80 to 70. Now the expensive one costs only 70. You need to retain this mean price of 65. Now in what ratio should they be mixed? Again we'll substitute into the mixtures and allegations formula and we'll get the ratio. So price of the expensive one 70 minus mean price 65 divided by 65 minus price of the cheap one 20. So 70 minus 65 5. 65 minus 20 gives you 45. So 5 is to 45, that is same as 1:9. So they should now be mixed in the ratio 1:9. So option D 1:9. An alloy consists of gold and copper in the ratio 1:7. So first of all we'll find the concentration of gold in that alloy. Concentration of gold will be 1 out of a total of 1 plus 7, 8. So this will be the concentration of gold in that alloy. 1 out of a total of 1 plus 7, 8. Another alloy consists of gold and copper mixed in the ratio 3:5. So concentration of gold in that alloy will be 3 out of a total of 3 plus 5, 8. In what ratio should they be mixed so that you get an alloy with gold and copper in the ratio 1:3. So in the mixture, the concentration of gold will be 1 out of a total of 1 plus 3, 4. So this is the lower concentration, this is a higher concentration, and this will be the mean concentration. So in what ratio should they be mixed? So we'll just substitute into the mixtures and allegations formula. That is a quantity having lower concentration to quantity having higher concentration. This ratio is given as higher concentration minus mean concentration divided by mean concentration minus lower concentration. We'll just substitute into the formula and we'll get the required ratio. So higher concentration, that is 3/8, minus mean concentration, that is 1/4. divided by mean value 1 by 4 minus lower concentration is 1 by 8. To solve it, we will multiply both numerator and denominator by 8. So here and here I will multiply by 8. Now 8 and 8 cancels out. So here you have 3. 4 divides 2 times. So 3 minus 2. That is in the numerator. Here 4 divides 2 times. So 2 minus 8 and 8 cancels out. You have 1. So the required ratio will be 3 minus 2 is 1. Denominator is 2 minus 1 is 1. So the required ratio is 1:1. So if they are mixed in the ratio 1:1, then you will get this alloy in which concentration of gold will be 1 out of 4. So required ratio is 1:1, option A. An alloy consists of gold and copper in the ratio 1:15. So first we will find the concentration of gold in that alloy. That will be 1 out of a total of 1 plus 15, that is 16. So 1 out of 16, that is the concentration of gold. Another alloy consists of gold and copper mixed in the ratio 1:3. So concentration of gold in that alloy is 1 out of a total of 1 plus 3, 4. In what ratio should they be mixed so that you get an alloy with gold and copper in the ratio 3:13? So in the mixture, the concentration should be 3 out of 3 plus 13, that is 16. So this is the lower concentration, this higher concentration, and this is the mean concentration or mixture value. So in what ratio should they be mixed? So we'll just substitute into the mixtures and alligations formula and we'll get the required ratio. Quantity of having lower concentration to quantity of having higher concentration. This ratio is given as higher concentration minus mean concentration divided by mean concentration minus lower concentration. We'll just substitute into this equation and you'll get the required ratio. Higher concentration is 1 by 4 minus mean concentration is 3 by 16 divided by mean concentration 3 by 16 minus lower concentration is 1 by 16. I'll multiply throughout by 16. So all the fractions will become numbers. So 4 divides 16 4 times. I'll just mark it here. So this is 4. 16 and 16 cancels out. So 4 minus 3. That is in the numerator. Here 16 and 16 goes off. So you have 3 minus 16 and 16 goes off 1. So 4 minus 3 is 1. 3 minus 1 is 2. So the required ratio is 1:2. So if you mix them in the ratio 1:2, you will get the alloy with gold and copper in the ratio 3:13. That is in this concentration. So the required ratio is 1:2. That is option B. An alloy consists of gold and copper in the ratio 2:14. So first we'll find the concentration of gold in that alloy. So concentration will be 2 out of a total of 2 plus 14, 16. Another alloy consists of gold and copper mixed in the ratio 5:11. So concentration of gold in that alloy will be 5 out of a total of 5 plus 11, 16. In what ratio should they be mixed so that you get an alloy with gold and copper in the ratio 1:15? So we'll find the concentration of gold in this alloy, that is 1 out of a total of 1 plus 15, that is 16. Now this is the lower concentration 2 out of 16 and this is a higher concentration 5 out of 16. Now if you mix them in any particular ratio, the mean value should lie between the lower value and the higher value. Now 1 by 16 is less than 2 by 16. So that is not possible at all. Now if you take only this alloy, then you will get the lower value, that is 2 by 16. If you take only this alloy, it will be the higher value 5 by 16. If you mix them in any particular ratio, that mixture value or mean value, it will lie between 2 by 16 and 5 by 16. It cannot be lesser than 2 by 16. It cannot be higher than 5 by 16. So 1 by 16 is lesser than the lower value. That is not possible. You can mix them in any ratio. It will lie between 2 by 16 and 5 by 16. It cannot be lesser than the lower value. It cannot be higher than the higher value. It has to lie in between them. 1 by 16 is lesser than the lower value. That is not possible. So final answer is not possible, option D. Let me briefly explain how to prepare for your aptitude test. First of all, you need to familiarize yourself with all the questions that have been worked out here. These are the questions that keep on repeating in many of the aptitude tests. After that, you need to attempt practice tests. According to me, you need to attempt at least 10 practice tests before your actual placement test. Here, I will be giving you 10 practice tests, and these practice tests will be ideal for you to improve your test scores. The 10 practice tests are available at a cost of only Rs 200. So all that you need to do is make a payment of Rs 200 either through Google Pay or through PhonePe or through Paytm, and you will receive the 10 practice tests. The details of the payment comes next.